It's quite fascinating. Everything, really. From very simple processes like trees growing to the quantum field theory. Pretty much anything you can think of is a fascinating concept, whether it's tangible like atoms or intangible like thoughts. And I was considering something I've considered before, which is how the human mind sometimes desires something as simple as a hug. And I get the reasons, of course. Getting closer to someone because we're social creatures triggers dopamine, the warmth makes us feel good, etc., etc. But it's still very fascinating because such a seemingly mundane action, wrapping your arms around someone, then pulling them in, very, very odd. Like, why would it not be that grabbing someone's arm feels good? It's just a random action. But something about the hug, for many numbers of reasons, makes us close, it warms us up, it's a sign of affection. All these small reasons add up to make a hug oh so desirable. But trying to think about it at the quantum scale, as is everything fascinating about the quantum scale, it is also fascinating. Because you see, just trying to process how a single cube of wood is interesting, the way the electrons and up and down quarks interact with each other and the Higgs field gives it mass and all those things. Thinking about something more complex, like the human mind desiring a hug, describing it in quantum terms is truly something interesting. So let me do that for you. If you don't understand quantum terms, then you can watch some videos from Science Click English, or Science Click if you speak French, or Science Click Espanol if you speak Spanish. I do not speak Spanish, no hablo español. But he explains quantum physics quite well. Now, regardless of whether or not you understand, I will try to explain at least a little bit. So first, the fundamental particles. This is the standard model of physics. And basically, a particle is a disturbance in a field. So you have electron fields, photon fields, which is what makes light, and all these other fields. And in the universe, when they get disturbed, that's what we call a particle. So a single electron is technically just a disturbance in the field. Now these fields do interact. So you have some up quark fields and down quark fields. The quarks are very strange. They seem very random. You have like the charm and the strange quark, which don't seem very logical, the top and bottom quark. So yes, but basically they're fundamental particles. They make up everything. So an atom, as you may know, is made up of a nucleus and an electron, or multiple electrons. So the nucleus is made up of protons and neutrons, which are made up of quarks. Up and down quarks have their spin directions. If you want to look into spinors and rays and points, that is much more complicated. I won't explain that now. But basically, they're made of these little disturbances and fields that interact with each other. Now, an electron, very far away from the nucleus, flies around it extremely fast, or multiple electrons. And there's also a couple states it can be in. The higher up or the further away from the nucleus, the higher energy it has, which is why when it drops down from a state, then it releases energy, typically in the form of a photon. Now, this electron flying around, if it's not an ion, which means it's either missing or has an extra electron, then it has the same amount of electrons as protons, and the charges cancel out, so it is neutral. So the electron, the protons, and neutrons would just kind of fly around, and the Higgs field is basically what gives inertia or mass, because mass is resistance to acceleration. So the Higgs field is this another invisible field that basically just resists certain things. It doesn't resist photons, and it resists some things less than others, and the quarks resist with the Higgs field. And when it gets resisted, that's resistance to acceleration, which is mass. So what mass is just resistance using the Higgs field. So you get mass from the atom. You also get charges from the atom and resistance from the atom. Atoms have many properties. But when you get a lot of these atoms together, they form molecules. So you have little collections of atoms. They're chemically bonded. Sometimes they share electrons, which is what holds them together, or they pass electrons between each other. Virtual photons can, there's a lot of ways they can hold together. So when those all collect together, you have a thing. You can watch Vsauce's video on what is a thing, or what is stuff. I can't recall the title of it. It's very interesting. But basically, you have an object. So all of those atoms form molecules, which form things. And touch isn't really touch, it's just the electrons resisting being touched together. However, there is sort of a form of touch, which is the exclusion principle, which basically says that two quarks or two electrons or two of anything can't be in the exact same space at once. So that is basically the most fundamental form of touching. So once you have an object, there you go. Now obviously there's a ton more to it than that, but that's pretty much it. Now, these objects can be some more stable than others. They can make certain shapes, like proteins. They are very, very complicated shapes, and they have weird forces, and they can be unstable in certain areas, stable in certain areas, and that's what determines how they interact with other things. So, in certain formations, with a human soul and spirit, you have a brain. And then you have these neurons. I won't get into the proteins and stuff and how they interact because it's super complicated and honestly just redundant. But basically, the way they interact is they send electricity to each other. And it's basically just a wire system. It's a computer. Our brain is a computer. And there's gajillions of wires connect to each other. And it's like a simple, okay, is this true? Yes. If so, do this. If not, do this. Except there's a lot of those questions, and they branch out more than just yes and no, and they react with multiple things. So there's a lot of systems to it, and of course the human consciousness triggered by the soul, or if you don't believe in souls, then you don't know what it is because science can't explain a soul. But with our consciousness, what we receive through light, through our nerves, through all our senses, along with what we think in our brain, kind of gives us a general idea of existence. So, assuming you have functioning senses, what you're seeing isn't really what you're seeing. It's more of the disturbances in the photon field interacting with the electrons and other parts of your proteins in your eyeballs and stuff, and then the electricity from the EM field being sent to the collection of proteins and other molecules in your brain, which then triggers sight. It's very complicated. But basically, that's how your experience works. Interactions with things at a very, 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 very tiny scale in the quantum fields. Now, the desiring of a hug. This is where it gets somewhat more interesting. So, these collections of wires, over time, have evolved through natural selection to become better. The ones that had not so great series of wires died. The ones that had better series of wires lived. So, certain series went together. And one series is that if you're with a human, then they can help you live and you help them live. And that benefits the both of you, which makes you survive better. So our brains have wired to become social and realize, hey, let's stay together. Now, it uses dopamine, which is another one of those things I won't get too deep into. And basically that's joy. So, when it detects, hey, person I could be friends with, which is sort of what love is, it releases dopamine to tell you, hey, this is a good thing. If you never got dopamine and pain or anything, you wouldn't know anything. Your brain would take in information and it would be saying, hey, wait, that's not a good thing. But without pain or without fear or without anxiety, you wouldn't know that. You'd have to logically think it yourself. That's the benefit of emotions. So when you get nervous, it's basically your brain saying, hey, this is bad, because if you didn't get nervous, then if you weren't thinking about the situation you were in being bad, then you wouldn't really notice. So emotions have a lot of things to go into, but I won't do that. That was a basic explanation. Now, one of the things with dopamine is it makes you feel good, which is why humans desire it, because feeling good feels good, of course. Drugs give you a lot of dopamine, and that's not good because it makes you addicted and all that stuff. But basically, don't get addicted to the joy and don't deprive yourself of it or you'll feel bad. Now, a hug. It's a good thing because our brain says, hey, this person has chosen to hug me, which means they like me, and it means they're willing to help me survive, and I'm willing to help them survive, and it's warmth, which is good because cold is bad, so we should keep our body heat up, and I'm close to someone else, so it's a bunch of good things, and your brain enjoys it, which means the way certain up and down quarks and electrons are arranged in certain ways, surely disturbances in fields, these collections of disturbances in fields come together to form certain things that interact in certain ways, like a massive computer with insanely complicated codes, with evolution over time, which is really just space-time, because we all move at the speed of light, but we just exchange space with time, to desire a hug. And I don't think there's a God. That would be interesting if it wasn't, and that just, if there was no God, if it just, that just happened. So yes, my desiring of a hug, a kiss, love, and other things related to that, affection in general, is immensely fascinating. I hope you enjoyed my quite simple explanation of the quantum field theory and electrons and emotions and neurons and other things like that. Goodbye, and have a lovely time wherever you are.